Find the equation of the tangent line to the curve of f equals x squared when x equals negative 3. I cannot emphasize enough the importance of these problems. That problem is going to be on FRQs. It's on an FRQ this week. It's going to be in multiple choice. It's going to be some form of that's going to be seen throughout the entire year. So it is crucial that you know what to do here. Equation of the line tangent to the curve f of x equals when x equals negative 3. Anytime you hear this, you need to think, I've got to find three things.
Slope y-axis.
I've got to know what x is, I've got to know what f of x is, and I've got to know what f prime of x is.
I got 2 out of 3.
All right? If I know those three things, I can solve the problem. What is x?
Negative 3.
Negative 3. Okay? So now this becomes what, instead of just what f of x, what is f of negative 3? When I put negative 3 in here, I get 9 out. Right? Now, what is f prime of x? You could do this before, but f prime of x, what's f prime of x squared? 2x. So we're wanting to know f prime at this specific point, at negative 3. So that's going to be 2 times negative 3, which is negative 6. When you see equation of the line tangent or equation of the tangent line, you need to write this down immediately because you know that's right. You know it has to be there. If you see equation of the line parallel, you know you're going to have to find those things, so find them. Now, what does my answer look like then? It's y minus y1, which is 9, equals m, which is negative 6, x minus x1, which is negative 3. And it's perfectly acceptable to leave the answer like that in an FRQ. Now, if this is multiple guess, that answer may not be there. If it's in multiple guess, they may have cleaned it up a little bit and got it to something like this. Minus 18, y equals negative 6x minus 9. Okay? But I'm telling you, on an FRQ, stop there. If it's multiple guess, you've got to be able to see that it goes all the way down to there. Okay? Is that complicated to figure out?
Not terribly.
Okay. Sam, it's about an hour since I told you you'd be able to solve these by looking at them an hour ago. So look at that. You do know what you're doing here. Let's look at something that could be a little bit more challenging to us. Look at these two problems. Are they the same problem?
No.
What's different?
In the one on
The x instead of 4 for the threshold.
Yeah.
And the 5x.
Right. They're very similar to one another. So to find these derivatives, you're going to do very similar process. Let's find the derivative to this one over here first. So 3 over 5x to the 4. Wes, what have we got to do to find this derivative? What's the first thing we need to do?
Put the 4 in front of the 5.
But x to the 4th's in the denominator.
Oh, yeah.
You gotta get in the numerator.
How do we do that?
Be 3/5 x to the negative 4.
3/5 x to the negative 4th. Okay. Colin, where are we going from there then?
Then you do 3 times negative 4 x to the negative 2.
Negative who? Ooh. Yeah, negative 5th. Right, yeah. I went the wrong way with it. So it's, now, so how would we write our final answer?
Negative 12 over 5x to the negative 2.
5x is 5. Yeah.
When you move it to the denominator, it'll be to the 5th power. Okay. Penny, what do we got to do different over here now?
5 to the 4.
Which is 625. Okay.
3 over
All right. And now we do the same thing we did over there. Negative 4 times 3, we get negative 12 over 625, x to the negative 5th. And we can simplify that to negative 12 over 625 x to the 5th power. Now, it's very important that you are doing a good job of labeling your work here, okay? And when I say that, I need to write y prime when I start taking the derivative. This up here, I'm not taking the derivative here. I'm just rewriting my original function here. So it's okay to leave, you shouldn't write y prime there. But once you start finding the derivative, make sure that it's clear that you've written it as y prime or f prime or whatever the function is there. Okay? Well, let's look at 2 more problems here. How are these different? Again, we've got a parentheses in one of them.
That's like the same.
In one of them, on the one on the left, only the x is going to be moved up top, and on the one on the right, both of them are going to be moved up.
Very good. So we want to start off here as 3 over 5 x to the positive 4 now. Okay?
Which is going to be...
We did that right, yeah.
9 over 5 x.
No, 12 over 5. It's going to reduce x minus
12 over 5 x cubed. That's what our derivative is, okay?
We have to put y prime. Yeah,
Yep.
you already did.
Yep. All right, so that's what our derivative is. Now here, this 5x is in parentheses, so we're going to move all of that up to our numerator. We'll say y equals 3 times 5x to the 4th power, which is 3 times 625 x to the 4th power, which is 1875 x to the 4th power, I believe. And all of that's just y. I haven't taken a derivative yet. Because all we've done is clean up, yeah. So now y prime becomes, 20 carry you 2, 28, 30 carry you 3, 32, 5 carry you 3, 7,500 x cubed, if I did any math right there. I don't know. I'm not good with numbers sometimes. 4 times 5, 20, 30, 32, 35, 37. I think so. Okay? So just be careful of your grouping symbols that you see, okay? Just be careful with those. Now, what about when we get to that, though?
Factor.
We could, but it wouldn't help us any.
I want a factor.
Okay? We could, but it won't help us any here. The directions say find the derivative, f prime. What do you think you ought to do?
Do it of all.
You define the derivative of each thing. So what's the derivative of x to the 4th?
X cubed and where?
4x cubed. Minus,
Mine
what's the derivative of 4x squared?
negative 8x
Okay. Plus,
plus 7.
just 7. What about the 24? 0. Right? 24 it has, oh, no. It has a derivative.
But not at x.
The derivative is 0.
Why is it
We learned that earlier.
24 is constant, remember?
number? Yes.
24 is constant. So 0 and no derivative are 2 totally different things. We're going to talk about no derivatives later on, but we won't get there just yet, okay? So that's the derivative. Now, think for a second. How hard would that be to do by the... I mean, it would take you a good 15 minutes to just write that out and go through it there, okay? But now you can look at it and know what the answer is. Now that problem on the FRQ gets real easy, doesn't it? Boom, just real easy to do. Okay, so that's, and what if I put 7 more terms out here? Does it become any harder to do, really?
Tedious.
Just a little bit longer to do, but boom, it just works out real well.
So what do you consider the negative 24?
Because the derivative, negative 24, is a constant term. The derivative of a constant is 0. So it's okay to write down plus 0 here, but it's not necessary. Think about graphing just this part of it, the negative 24. That would be a horizontal line, so the derivative is 0, okay? All right, good. Easy, right? Much easier than what we've done before. Solve the problem then. Find the derivative. It's negative x cubed. Oh, yeah. Oh, you're right. When we do that, we'd have negative 3x squared over 3. Yeah. 4x cubed becomes 8x squared.
Wait, wouldn't it be 12x? Yeah.
Would it? Yeah, it would be 12, wouldn't it? 4 times 3 is...
Oh, yeah.
4 times 3 is still 12, isn't it?
I keep multiplying by what I'm already reduced.
Yeah, your mind's just going ahead of you there.
That's bad.
So we could get 11x squared plus 5. Right? Okay? Is that complicated there? All right. So, pretty straightforward. As long as we keep it nice polynomials like this, it's real straightforward. Now, let me tell you what you can't do yet, okay? You can't do something where we've got multiple things raised to a power. So if I give you like 2x plus 2 squared, you can't find that derivative yet. We'll learn how to do that Monday, I think. But you can't find that derivative yet. One last thing we do need to learn, and these are things you need to memorize, okay? The derivative of sine and cosine. The derivative of sine is cosine. The derivative of cosine is minus sine. Do y'all remember seeing this in the first lecture?
Yes, sir. That means derivative.
The derivative of cosine with respect to x. Okay, don't worry about that yet, but that's going to mean something later on for us. The derivative of cosine is minus sine. These are two things that you must memorize. Okay? You've just got to know the derivative of sine is cosine, derivative of cosine is minus sine. Memorize those. So what's the derivative of 5 sine x?
5 cosine.
Y prime is 5 cos x. Right. What's the derivative of cos x over 5?
Negative sine x over 5.
Negative sine x over 5, or negative 1/5 sine x, either one. And what about this last one out here that mixed in x squared and cosine? What's the derivative of x squared? 2x.
2x sine.
It's got to have a sign there. Because derivative of cosine is minus sine, right? But we've got a minus in front of it, so the two minuses would cancel each other out. So we get an answer of 2x plus sine x there for y prime. Okay?